Okay, so let's start. Let me check recording. Yeah, so let's start. Okay, so till now we were studying binary search was applied only on the integer values. So many a times it happens like you need to apply binary search on double or float values like floating point number, decimal values. So decimal points, binary search. Okay, this is also called double value binary search or epsilon binary search. Epsilon, why epsilon? Because epsilon very small value, very small value. Okay, so 1 e power minus 6, something like this. Okay, so that is why it is called double value binary search. So let's see what is the problem or what happens here. So in double value, like initially, suppose in our normal binary search, what we were doing, we only used to take integer value like plus 0 plus 3 by 2 came to be 1. Okay. But here, if you see the actual value, the double value, it is 1.5. Okay. So the double value comes out to be 1.5. And since you are taking double values, it won't ever, finish. It is an infinite binary search if you see. Why? Because the numbers after decimal, they keep on expanding, expanding. They are never, converge. Like suppose if you have this range, like this low is 52542 1. Okay, and your high is 1.52542 and here 0. So next time if you see the mid comes out to be 1.5254205. Okay, so one further significant bit was increased. Okay, so each time you will see, and based on this, you will update the value, and again, you will get some mid, and you will again get some high. So this keeps on expanding, keeps on expanding. Okay, so this binary search is infinite, infinite binary search. Because the decimal after decimal the number of digits can be infinite, that is why this becomes an infinite binary search. And you can't calculate it extremely precisely, like it won't happen like you need to after the decimal you need to find 10 power 5 digits. And because after only after in most of the competitive programming questions you will see like only we need to calculate answer up to 6 decimal places after the decimal. Okay, that is why in many a places you will see this. So let's see what happens in a standard binary search first. Okay, like in a standard binary search, what happens in a standard binary search? In a standard binary search, what happens is each time your search space is reduced by half. Search space is reduced by half. Okay, so what happens? Like suppose if your search space was of length 8, it gets to 4, it gets to 2, it gets to 1. So converges. Okay. So at one point, all of this, converges. Like suppose what happens, your range was 0 to 100, and your answer was 30. Suppose it may happen. First of all, it becomes 0 to 50, in one iteration. This was one iteration. In second iteration, what happens? It becomes 0 to what? It becomes 25 to 50. Correct? In second iteration. In the third iteration, it becomes somewhere like 27 to 30. So as the number of iterations increase, you are getting closer and closer to your answer. Suppose your answer was 30, this was the answer. So as the number of iterations increase, you are getting closer and closer to your answer each time. Why? Because your search space is being reduced by half. Earlier it was 100 here, it's 50 here, and this keeps on going on, keeps on going on. Like it is 25 to 50, or although like it is 25 to 50 here, next time it becomes sorry, my bad, I wrote 30 here, 25 to 30, oh 50, sorry. Okay. 25 to 50. Next time it gets 25 to 37.5. Okay. Next time, next time, suppose 37 only initially because we are considering standard binary search. Okay. So 37. Again, this time it gets to 25 to 31. So you can see, like as the number of iterations are increasing, you can see like the answer is, coming closer and closer to 30. So that is the reason, like by binary search, what does binary search do is it keeps on reducing your search space in half and keeps on doing it until and unless you are so much close to the answer, so much close to the answer, like the difference between the actual answer and your answer is negligible. Since if the answers are integers, you can calculate them clearly. But suppose if the answer are in floating point value, like floating point doubles, floating point or double, you can't calculate the actual answer, but you can reach to the answer so close that the actual answer and the answer you calculated, it is not too much far apart, and we can consider it. That is why in most of the CP questions, you will see the range like the answer should be well within 10 power minus 6 range. So what does that mean is you need to calculate up to 6 places after decimal. So your precision should be this much. Okay, your answer can't be differ more than this much. Okay, so that is what it means. So what happens actually in floating point numbers, like how are they different? Okay, so suppose this time your range is 0 to 1. Okay, earlier it was 0 to 100, now it is 0 to 1, and again your answer is 0.3. So what happens? This time we are doing for double values. Okay, so what happens? First of all, it gets to 0 to 0.5, then it gets to 0 to 0 to 0.25 to 0.5, suppose. Yeah. Okay. Next time you get it to 0.25 to suppose 0.375. Again, next time you take it to 0.25 to, I think it will come 0.31 something something. Okay. Next time it will go somewhere around 0.27 something something, like some more digits would be appearing here and 0.31. So as you keep on iterating, you will see you are getting closer and closer to 0.3, which was your answer initially. Okay, so as you increase the number of iterations, second iteration, third iteration, fourth iteration, fifth iteration, as you keep on increasing the number of iterations, a time will come that your answer may not exactly reach like 0.3, but like 0.300. Actual answer is this, but your answer may reach something like 0.30000001123, something like this. It may get it to something like that. Okay. Although it is not exactly zero point 0.3, but if you see six decimal places here, it is all zero. So the answer gets so much close to zero point 0.3 that the difference is so negligible. Okay. This difference is negligible. This extra difference, this is coming, but this is negligible. So we ignore this and we take this as our answer. Okay. So that is the thing. But now how to see how much we should do the number of iterations? Like how to check the number of iterations? Okay, for that, we have one trick. You can say trick only. What else it is? You can say like, what do we say? You can just write trick here. Although it is not a trick, you can see it mathematically. But what happens is, uh, each time your search space was being reduced to half. Okay, so suppose 10 power 5. If n was 10 power 5, then how many number of iterations in standard binary search? It would be log base to 10 power 5. Okay, so 5 into log base to 10. So somewhere around 20 operations. Okay. So 20 operations were needed in order to, in the standard binary search if n was 10 power 5. Now, what would happen in case of suppose 10 power 18? 10 power 18, nearly 72 operations would be needed, 72 iterations. Okay. So suppose what happens is there is some very large value here, then there is a decimal point, and some number of values here. Suppose 10 values also here. Okay. So in this case, what happens is, suppose here, what will be there? Suppose 118 is here, decimal point, and some values. So in this case, we need very high precision. Okay. Suppose we need 10 precision up to 10 digits. Okay. So what happens this case? Like how many times should we run this? So since 118 itself needs 72 operation to converge and further decimal points. Suppose there was no decimal point here. So this value would be, 1e28 nearly. So we can write it 28 into 4. So how much is it? 4 So nearly 150 iterations. So in 150 iterations, although you will be never asked to, calculate up to 10 uh, so much precision like for 10 digits, but suppose. So in that case, we need only 150 iterations at max. 150 iterations at max for any loop. Okay. So what we can do simply is we can simply do 150 iterations. Like instead of doing while low less than equal to high, because in case of double values, this runs to infinite. This goes infinite. Okay. We will run the loop for only a fixed number of iterations. So for up to suppose 150 iterations, 0 to 150 iterations, we simply do the same thing like calculate the mid, low plus high by 2, follow our standard template based on some condition. We either update low or we update high. Okay. But this time we don't do plus one. Why? Because the answer is we need to calculate a very precise answer. So instead of doing if you do plus one here, then the problem is you may deviate too much from the answer. We need the answer so much like we need the answer to be only like we only can accept this much error, suppose. Like, and if you do a plus one, then you are creating so much of error. So what we do is we simply put low equal to mid and else we put high equal to mid. Binary search automatically, handles the precision because each time low plus high by 2 is being done and we are running it for, fixed number of iterations. So that is why a problem will never occur. So yeah, this is the case. Like this is what is known as, decimal binary search where in order to avoid this infinite thing like infinite binary search, we iterate for over only a fixed number of iteration till we are satisfied like now for 150 iterations we are satisfied like this will definitely give us our answer so very much close to the actual answer. Just as I told you in this zero point 0.3 case, like it won't give you perfect answer. If you see and you print the value, if you print this value, you will see something like this. But it will still pass. Why? Because your actual answer was only to be up to 10 power minus 6 relative error. Okay. And since here 6 decimal places are correct, so your answer will be accepted. We don't expect a perfect answer, but we expect a near perfect answer. Okay. So that is the case. So this is what binary search helps us in. So it keeps on reducing search space, keeps on reducing search space till the difference is so small that it is negligible. So that is what our approach is. So let's see a question on it. Okay, so you can come on the Codeforces edu section and you can join the ITMO course and inside that binary search step 2 and you can come to this problem. Okay, so what we need to do here. So what we are given is there are n ropes and you need to cut them into k pieces of the same length. And you need to find the maximum length of piece you can get. Okay, so what the question is saying is you will be given a number of ropes and a value k. 4 and 11. These are number of ropes you have and this is number of pieces you have to do. Number of pieces if I am correct. Yeah. So this is the number of pieces of ropes I want. Number of pieces of ropes I want. Okay, so this is the case, and you will be given four ropes. it can be of same length and they can be of different length. Okay. So here if you see 457,539. So this is the case. Okay. Now what we need to do here is we need to find the maximum piece of rope we can do, because number of pieces of ropes I want, all of them should be of same length. Okay. All of them should be same. Okay. So suppose I decide like I will make all the ropes of length one. So if I decide for length to be one, if length to be one, then we can make 802 ropes, 802 pieces out of this, plus 743 out of this, plus 457 out of this, plus 539 out of this. Okay, and all of this sum comes out to be greater than equal to 11. If this sum comes out to be greater than equal to 11, then we can accept this length. Okay, so suppose next time we take length equal to 10. So 80 out of this, 74 out of this, 45 out of this, and 53 out of this. Okay, so this time how much? Still it is greater than equal to 11. So still we can do it. Okay, so this is what we need to do. Like we need to, and since 10 is greater than 1, then answer not currently, like current answer would be updated to 10. Okay, so this is what we need to do. But the only difference here is instead of making integer cuts only, like it is not necessary that the length is 10 only, the length may also be in decimal also. So suppose length can also be like 100.5, 100.25 or whatever. So this is the case. So if you see carefully here, you can observe the pattern. Like here, what we are seeing, like if some value, like if length equal to 100 is not possible, like if suppose like let's take length equal to 1000. Okay, length equal to 1000, we can make zero pieces out of this. Zero, 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 all of them give zero, and clearly this is less than equal to 11. So we can't take length 1000, like for a single piece we can't take its length to be 1000. Okay, because this gives us zero pieces and we want 11. So since 1000 is not possible, any length greater than 1000 is also not possible. So clearly we can see a binary search on answer thing. So this is a binary search on answer. But the only difference is the value can also be double. Okay. The value can be in decimal also. So what we'll do is we'll just apply a trick that we just learned. What we'll do. Similarly, iterate over 100 or 150 iterations, because here number of the array length is small, like it is 1e5, so you can do 100 iteration also, but you can fix it like put always do 150 iterations. It won't cause any problem, because at most it will be 150 into n, and 100 into n also is nearly the same, so you can do 150n. So what we will do is simply take low and a high, and update yani take mid. For mid, check the answer. For mid, we will check the answer, and how we'll check? Simply, divide each of the length by the mid value. Like suppose, uh, if we take, if we took length equal to 10.5 or something like that. Suppose we take length equal to 10.5. So simply divide 802 by 10.5. Calculate the number of pieces you get, and you can, add them just like we were doing it. Like if length was 10, divide by 10. Okay, 80 pieces, 74. Again, oh, sorry, 10. Again, we get from here 74 pieces. Okay, yeah. So it can't be 80.2 pieces. Like you do double division here. No, no, that won't be the case. Why? Because 80 point, like it won't happen like we take 80 pieces plus point 0.2 something. No, that won't be happening. We will take only 80 pieces out of this. This length can be in decimal, but number of pieces are always integer. Okay. So 80 out of this, 74 out of this, 45 out of this, and 53 out of this. And if the total sum is greater than equal to k, then definitely that answer is possible. So if on checking, that answer is possible. If check of mid becomes true, then simply check for a larger value, plus 1. And otherwise, high gets equal to mid minus 1. Okay, so this was the only case. The only The standard binary search on answer from the last video. And just the only catch here is for this decimal part, this epsilon binary search. Okay, let's see the code also. It is simple. See here. So simple the template we are following. I have done 100 iterations because n was 1e5. So I have thought like 100 would also work and it worked. So keep a counter variable, divide by mid. Here I iterate over the array, the ropes array, and simply divide by mid and count. If count is greater than equal to k, return true, otherwise return false. So this got accepted. I don't think it was a problem. It was an easy problem. So the only thing you need to do here is do this trick and see here also. Like see one thing here. I am not doing low equal to mid plus one or I'm just keeping it as mid because we are after 100 iteration it will stop. So we'll get very much close to the answer so that the answer is and one thing also like whenever you need to print up to some precision like in C++, whenever you need to print up to 6 decimal places precision, then you can use this syntax of cout fixed. This fixed keyword is important and set precision. And in the method call, you can simply give here the number of decimal places that you need precision for. And since here it was written 1e minus 6, I gave 6 length precision. Okay, so that is the case. Yeah, so this was only this much. And now let's start. Let's see another thing. Like let's do what we call as binary search on prefix sums. Binary search on in the first class. What did I tell you? Like it is not necessary that binary search is always performed on the arrays. Okay, it is not necessary that binary search is only done on the arrays. You can do it on string or anything that follows a monotonic order, sorted string. But the only thing that should follow is a monotonic parameter or order should be present. Monotonicity should be there. Like this was the main condition. Okay, and if you know about prefix sum, if the array is positive, like if all the elements in the array are greater than equal to 0, so definitely you will know that prefix sum array, it is sorted array. Why? Because see, even though this array is not sorted, but the prefix sum array will always be sorted because the sums will keep on increasing because there is no negative element in the array. It is guaranteed. So you will see if we create a prefix sum array, it is always sorted. Okay, so we can apply a binary search on prefix sum array. Okay, so this is one thing we got to know. So let's see the question, and you will get a better understanding by question. Like it is not, I would say it is not a separate topic. Like since now binary search, binary search on answer. Now you can apply binary search on anything you see a monotonic order. Since we saw that prefix sum follows a monotonic order because it is increasing, so that is why we can apply binary search here also. So let's see a question on that. So this is a question. You can give it a read. You can see the code here and try yourself first. But it is also difficult question. But bear with me and we'll get to know this together. Okay. So yeah. First, let me explain you the question. Like what is the question? The question says that you are given you are given number of months in a year. Like there are n months in a year, and you are given the number of days in those months. Case 131. Okay. So there are 3 months in a year, and in the first month there is 1 day. In the second month there are 3 days, and in the third month there is 1 day. Okay. Also, you are given a value x. For x days, you are going to visit one of your, what do you say, relative. Okay, so for X days, you are going to visit your relative in a continuous manner. Like, suppose if you visit your relative on the first day of the second month, when you will, like, suppose this is how the calendar goes: one, one, two, three, and one. Okay. So what is this? This is the first date of the month one, first date of month two, second date of month two, third date of month two, and first date of month three. Okay. So this is the calendar of year. This is your calendar. Okay. So for X days, you are going to visit your relative, and those X days are going to be contiguous. Like suppose X equal to 2. So for any two contiguous days, you are going to visit your neighbor. Like these days can be either these two, these two, these two, these two, but they should be contiguous only. Okay. So what you need to find is, yeah, maximum number of hugs. Okay. You need to find the maximum sum over this X. Okay. I think, yeah, yeah. So what you need to do is you need to find the maximum sum over this X. So uh, this will be a calendar, like a calendar will be there, and here you see what is the maximum. Since you got to go over all subarrays, like the sum of this subarray is 2, the sum of this subarray is 3, the sum of this subarray is 5, and the sum of this subarray is 4. So out of these, what is the maximum? It is 5. Correct? So 5 is the answer. You can see that also. But you may think like this is a very easy question. What we'll do, what we need to do, just simply go. We are given the dates array. Simply expand that. Like suppose here it is 10, here it is 5, it is 3. Simply expand this array. 1, 1 to 10, all values comes. 1 to 5, all values comes. Then 1 to 3, all values comes. And simply you can, create a block of x, use prefix sums and calculate and take maximum. But no, if you see the constraints, N is 2e5 and di is 1e6. So in worst case, what will happen? 1e6, 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 2e5 times 1e6. So if you try to expand this array, how many elements you need to write? 1e6. Again 1e6 elements. So total 2e5 times 1e6 elements you need to write. Okay, so it is not feasible. So 2e11 times, and you need to calculate prefix sums. Even though memory also won't allow you to write, 2e11 sums in an array. So thinking about the brute force, it is uh, you can't do that using the brute force. So you need some optimization. So what can be the optimization? Let's see. Like what we can do. So yeah, if you see carefully, like what is the optimal date to visit? Like instead of iterating over the all of the dates, if you observe something, let's see the observations. If you see, instead of going over all of the creating this array and going over all of the arrays, you can simply think like what is the optimal dates to visit? Like, see, we were expanding this array. Okay. So, and we needed to get the maximum sum. How we will get the maximum sum? The maximum sum we will get when we visit only on the last days. Okay. So it is always optimal that you take the last days. Okay. So suppose you thought of taking these 3 months. Okay. So like this was your calendar. Suppose let me draw a calendar so that you can get a better idea. Let's take the last one. 5, 6, 4, 2, 3, 1, 3. 4, 2, 3, 1, 3. These are the number of days in each month. Okay, and let's draw a calendar. 1, 2, 3, 4, 1, 2, 1, 2, 3, 1, and 1, 2, 3. Okay, so this is the calendar of the month of the year. Okay, and it will keep on repeating because again this whole array will come after it, because it is a, since it is uh, calendar, so calendar repeats itself. Okay, there are no leap years also. It is given like there are no leap years, and the calendar will keep on repeating itself. So it is a circular array type thing you can think of. Okay, so we'll come to that later, but first see here. Like, suppose I thought of visiting the, suppose I thought of visiting the neighbor on starting from here, and what is the x value given? X equal to 6. Suppose we take x equal to 3 or x equal to 4. Okay, we are taking x equal to 4. So, suppose I thought like I would visit them on these dates. Do you think it is ever optimal? Like, instead of visiting, like you visited one, yani from here you got only one contribution, correct? But you missed out on this three contribution. So if you see carefully here, it is always optimal to start from the last date of some month. Okay, it is claim. What is my claim? My claim is it is always optimal to take or to visit. I would say it is always optimal to visit the relative starting from I won't say starting from uh it is it is always optimal to visit the relative in such a way that when we leave we are on a ending date of some other month. Okay, so this is my claim. Like, we should visit the relative in such a way that whenever we leave, we are on a last date of some other month. Like, here, instead of visiting this way, like we go on one and we visit only on 1 2 1 2, we should visit on two and go to 1 2 3. Why? Because here you can see like we got two extra. Mm, You can see like here the sum was 3 plus 3 6, and here the sum is 3 plus 7 it is 8. So definitely you got two extra thing. Why? Because visiting on the end dates of any month definitely gives you an edge because you can get more out of them. So definitely it is optimal. Like you visit in such a way that you are on an end date of some month. Okay. So this is one of the observation. It is always optimal. Like it won't ever happen. Like suppose you may think a case may arise. Uh, what can be this if you think? Suppose you think 1 2 3 4. It is this line. Okay. So you may think like here I am getting 4 and I start visiting such a way that I take this because I am getting 5 here. Okay. But if you see carefully, if you ignored this 5 and started from this 7, first of all, suppose there was no 7, there was 6 only. Or suppose there was still 5 only. Okay. And still you thought of visiting from 4. So in this case, what will happen? You definitely missed on something better. Why? See, if you visited over this array, this starting from this 5 to this to a month end, you definitely got a plus 1 extra here. In this one, you got a plus 1 extra. Why? Because you got an extra 5 over here. So always there will never be a case where you visit something, where you visit on a date something like you visit and it does not end your journey. Your when you are leaving, it is not month end. This is very much, this is suboptimal. This is not useful. not useful. Okay, so you should visit in such a way that you are leaving at the end of any of the month. Now you need to check that like on what and like you can check that like I thought of visiting in such a way that I end on month two's date, on month two's ending, or you can visit in such a way that I end on month three's ending, or in on month four ending, or on month five ending. So this is the case. Like you need to find on what month ending you want to leave your neighbor. Instead of thinking on what day you visit, you should think on what day you are leaving. That is the catch here. So that will give you the optimal answer only. I hope you are clear like why we are seeing like on what day we should leave instead of on what day we should visit. We are seeing on what day we should leave. On what day we should leave instead of on what day we should visit. Okay, so we are considering this because this won't give you, seeing this will cause many much problems, but seeing this is easy because we know we should always be leaving on some month's date. So according to that, we will visit. So yeah, so this is the main observation that was present. Now what remains is the implementation part. This was your main observation. What we'll do is like what our approach goes like. First of all, we'll think like I want to visit in such a way that I leave on month one's ending. Second, what can be the other option? I want to visit in such a way that I leave on month two's ending, month three's ending, month four ending. So we'll keep on doing this. We calculate answer for each month ending and take maximum out of it. Okay. So what happens is, see here now. Yeah. So since you are given X days, okay, you are given X days, and on each day you are given some month. In each month, you are given what are the number of days in that month. So let me take this case 4, 2, 3, 1, 3. One prefix sum array we'll make for the number of days counting, like total number of days. Okay, 4, 6, 9, 10, 13. So this gives us idea how many number of days are there in each month. So suppose we need to find Uh, why we are doing this? Suppose because we have x days. Suppose x equal to 5 here, 4 here. Okay, we need to visit in such a way that we leave on this month's ending, fifth month's ending. So in order to do that, when should we visit? Okay, we should visit 4 days before this 13th day. Correct. So on what day we should visit? We should visit on the ninth day, or we can say on the 10th day. So because 10, 11, 12, 13. These are the days. Okay. So if you want to leave on day 13, you should visit on day 10, correct? So that is why we are, calculating this prefix sum array. Suppose it was 6 days, and you want to leave on day 13. For leaving on day 13, on what day you should visit? You should visit on day 7 or day 8, I should say. 8, 9, 10, 11, 8, 9, 10, 11, 12, 13. So how many days? 6 days. Okay. So 13 minus 6 plus 1. So definitely you should visit on day 8. So where does day 8 lie? Day 8 lies from this month to this month. Okay. So that is why we are calculating the prefix sum array. Now another thing is for calculating uh okay, so another thing that we need to see here is how to quickly calculate the total number of sum we can get out of a particular month. Another thing to calculate total number of total sum, I should say. total sum I can get out of a particular month. From a particular month, how much sum can I totally get? Like suppose if a month have 5 days, okay, so how much total sum can it generate? Can 1 plus 2 plus 3 plus 4 plus 5. If I visit it fully, it will generate this much sum. How much is it? You can simply say it n into n plus 1 by 2. Okay, I hope you know this formula. This is, sum of AP. So you can calculate this using the formula of sum of AP and arithmetic progression. Okay, so this is the formula. So for each day, for each month, you can calculate the total sum it can give by using this formula. Okay, so what does the prefix sum 2 gives? We can give another prefix sum. This is prefix sum 2. Here we sum the number of total sum that a particular day can give. You will see like what is the use of it. Uh, so let's see. 4 will give how much? 4 into 5 by 2, 20, 10. Okay. 2 into 3 by 2, 6 by 2, 3. 3 into 2 by 2, how much is it? So 3 into 4 by 2, 6. 1 into 2 by 2, 1. 3 into 4 by 2, again 6. Okay, so this is not prefix sum array. We need to, sum it also. So 13, 13 plus 6, 19. 19. Okay, 20 and 26. I hope this is correct. So this is the prefix sum 2 array. So what was your prefix sum 1 array? It is, total days. It gives you total days. Like it helps in finding on what day we should visit. From what day to what day we should visit. And this helps you give total sum. Like suppose here x equal to 6 was there. So 13. 13 minus 6, 7. We calculated we need to visit on day 8. Okay. So we thought of visiting on day 8. Now from day 8 to day 13. 8 to 13. How much is the total sum that we can get? For that, we have this prefix sum 2 array. So what will you do? What is the binary search part here? See, first of all, what is the binary search part here in this total days? It is to calculate on what day we should visit. Why? Because suppose we are on day 13. We are on day 13 and what we need to find is we need to find on what day we should visit. So day 13 minus 6, we got plus 1. Okay, so we should visit on day 8. Okay, so what we do is we found the lower bound of it. So as to we know on what month we should visit. Okay, so we find the upper bound of 8, upper bound, upper bound of 8. Let me write it here. Right, we calculate the upper bound of the value. What value? Uh, the value like on what date we should visit. Date to visit. And what does this give? This gives us the month on which we should visit. Okay. So this is what we want. Like we will calculate the upper bound of the date we want to visit. So this will give us the month on which we should visit. So let's see how is this working. It is only the implementation part. The logic is, mainly the same. The implementation is quite difficult here. I won't say difficult. It is only single for loop, but thinking it is quite difficult. So yeah, this was your array. 1, 2, 3, 4. 1, 2, 1, 2, 3. 1 and 1, 2, 3. Okay. And the prefix sum we calculate. I think I don't need this. Prefix sum is all that is sufficient. Prefix sum 1, 4, 6, 9, 10, 13. This is prefix sum of days. And prefix sum 2 is of contributions. Okay. So what was the prefix sum 2? Don't want to calculate it again. 10, 13, 19, 20, 26. So 10, 13, 19, 20, and 26. Okay, so this was your dates array, months array. Okay, and what is the value of x? Suppose x is equal to 6. Now I thought that I will visit on this date. I want to visit such that I end on a fifth month's last date. Okay. So for that, what I do? 13 minus 6 plus 1. So I need to visit on 8th day in order to leave on 13th day. Okay. It is not actually 13th day, but actually, if you see, it is the third day of month 5. Okay. So I am just saying it 13th day in order to check from prefix sums. But actually, if you see, it is the fifth, this is the third day of fifth month. Okay. And I thought that I want to leave on this day, this fifth month. I want to leave when the fifth month ends. Okay. So this is what I wanted. So, yeah. So that is why I'm saying like we need to find the upper bound of this value a. What is the upper bound? This is 9. Okay, so this gives us on which month we need to visit. We need to visit such that we need to visit it on month. What is this is month 3. Okay, so I should visit on month 3 in order to leave on this fifth month. Okay, but on what date on month 3 that we need to calculate. But for current time, just just think like we need to visit such that on the month 3 we need to visit in month 3 in month 3 on some date on month 3 in order to leave on uh, leave when the fifth month ends. Okay, so this is what I we have calculated till now. So now what we need to do, what we need now is like, see, now what we want that from this value till this value we want the total sum. Okay, total sum of what? Like total sum of how much we can get. Ignore this value currently. Why? Because we don't know on which day we want to visit. So total sum of all these values from here to here. Okay, so how will we get that quickly? For this, we can use this prefix sum to array. So, okay, so what we need is, yeah, how will we calculate that when I visit all the days in month 4 and all the days in month 5, then how much total sum will I get? Actually, it will be how much? 1 plus 1 plus 2 plus 3. I hope you are seeing how it is coming. This fourth month had 1 day and fifth month had 3 days. Okay, so total sum will be 7. And how will we calculate it using this prefix sum to array? It is simply 26 minus 19. Okay, so it will give us 7 only. So that is why we have calculated this prefix sum to array in order to calculate the total sum we can get out of a particular months. Okay, so this is what we'll do. Like we calculated the month, and after that month, like 1 plus that month, we'll calculate the total sum using this prefix sum to array. Okay, so it came out to be 7. So 7 is currently stored in the sum. But this does not contain the sum that we'll get when we visit from the month 3 days. Like till here, we wanted to visit on some day on month 3. We don't know what day that would be. Some day of month 3. Okay. So some day of month 3, we wanted to visit. Now we want to calculate what that day would be. Okay. So in total, there were 6 days. Okay. 4 are used here. So how much remains? 2 days remains. Okay, so on what day we should visit? 3 minus 2. Okay, so 4 days are used here. 3 remain, and out of 3, on what day we should visit? We should visit on the second days. Okay, second, 3, 1, and 1, 2, 3. This will be what we will be getting. Okay, so for calculating the sum of this value, we can just do sum of AP. Like we have the first term, we know the D is equal to 1. We have the first term and we know the number of terms. How we can calculate the number of terms? Simply you can calculate the sum of this value using this array. Okay, and subtract from x. So x minus this value sum. So how much we get? 2. Okay, so 2 days remain. So we want to visit the month 3 such that Well, we want to visit this month 3 on the second last date. Okay. So we are visiting on the second last date. So this is the month we are visiting on. Like second last date was 2. So we are visiting on 2. So we want to calculate the sum. Now we know the number of terms equal to 2, D equal to 1, and first this value, this A term, A is equal to 2. So we can, calculate this using AP formula. So for a particular month, we can calculate it like this. So I know it is, the implementation is quite hard. I won't say hard, but it is tricky. Implementation is tricky, but the logic is, logic is easy. So what does, binary search comes here? Binary search, came here for calculating the main thing, like on what day we should visit, on what month we should visit. Okay. So let me show you the code so you can get a better understanding also. I think there is some network issue. Let me check. Yeah, it is coming. Okay, so see here. Okay, taking the inputs, calculating the prefix sum and prefix sum to array. How? Prefix sum is simply we can calculate plus ARRI. But for prefix sum 2, we are using that formula n into n plus 1 by 2. Like here, ARRI is the number of days. So number of days into number of days plus 1 upon 2. So this way we can get the prefix sum 2 array. Now see this code. Although the code looks small, but calculating it is quite tricky. So see here. First of all, what is the total sum up till here? It is prefix sum of I plus 1. Okay, so what is prefix sum of I plus 1? I was referring like it is this 13. Okay, and what is the x value? X value would be given to you. So what you need to do is you need to find upper bound of total minus x. What does upper bound gives you? Upper bound gives you first value greater than. Okay, what is upper bound of x? I hope you know that much because if you don't know that, you need to check out other videos first. So upper bound of x gives you first value greater than x in the array. So this is what upper bound gives you. Okay, so we are calculating the upper bound. So we calculated the upper bound and this gives us the month's index. Like this gives us this index. Why? 13 minus 6, that was 13 minus 6 was 7. Okay, and 7, what is the upper bound of 7? This is 9. So we get this index. Okay, so now we know that we need to visit on some day on month 3. We don't know what that day is currently, but we know that it is definitely some day on month 3. Okay, so yeah, so we are calculating that. Uh, we got to know the month. Okay, now calculate the sum from that day. Like we are using the prefix sum to array for calculating this thing. Like what I did was, I got like I want to visit on the third I want to visit on the third month, some date on third month, but on what date I don't know. So for other we know like we want to calculate some of this value. So what I did, I calculated 26 minus 19. So this gives us the sum 3. Oh, sum 7s. How? 1 plus 1 plus 2 plus 3. So it is 7. Yeah, it is 7. Okay, so this gives us 7. Okay, and finally, uh, these are the number of days I have already taken. The taken variable contains the number of days I have already taken. How I calculate this? Simply, use this prefix sum array and calculate. So how many days you have taken? 13 minus 9. So total 4 days are already taken. We wanted to take 6. So subtract this. So left, what are the number of days left? This is x minus taken. So 2 days are left, and those 2 days I want to take from the third month. Okay, so we can calculate this. We can calculate like on what day we need to visit. That is will be the that just I told you. Like here we calculated how was left. Left was equal to 2 here. Okay, left was equal to 2, and what was this? Number of days were 3. So 3 minus 2 plus 1. So we will going to be visiting on second date. Okay, and D is so this is your A. This is your d equal to 1 and number of terms equal to left. N equal to left equal to 2. So we need to calculate sum of 2 plus 3. That we are doing using sum of AP formula. Okay. And finally, add that to sum and you can take maximum of answer and sum. Keep on doing this for all values, like keep on doing this for different month endings, and finally you can output the answer. I hope you are clear. You can, see my submission. You can see my username and you can see my submission on this question for your understanding. Okay. Or also for that circular array part, because the months are going to repeat themselves. So what you can do is, suppose this is your months array containing number of days 4, 5, 1, 2, 4. Just simply, copy this whole array one more time. 4, 5, 1, 2, 4. Okay. So now whenever uh, this way what happens is the circularity is, finished. Now whenever suppose the person wants to, end on this date, so he can, calculate from here also. Whenever he want to end on this month, he can calculate from here. Whenever he want to end on this month, he can calculate from here. Here he could not calculate because, previous was not present, but here he can calculate. So that is the reason, just push this whole array one more time. I hope you know this because, in order to, finish circularity, we can just push the whole array one more time. So that is the reason. See, I have read the array and, I have again pushed the whole array one more time in the same order. And I have again initialized n equal to error dot size, like it is 2n now. And I have calculated this whole thing for all indexes, like for each index. Okay. So I hope you got it. And this was a good question, I would say, on binary search and answer. So yeah, so I would say I think that's it for today. I think you should practice, some questions on binary search because it is a very good topic in competitive programming on CodeChef. You will find more questions of it. Codeforces gives slightly less questions, but it also gives in good amount. Okay, so keep on practicing.